morning, students. Just after the completion of group 15 element, that is a nitrogen family, today, that is in class 1 of the chapter Metallurgical operation. In class 1, I will try to complete the introduction part, some common terminology, and the general steps followed for the extraction of metal. So let us discuss one by one. The chapter name is General Principles and Isolation of Elements. General principles and processes of isolation of elements, or we simply say that the metallurgical operation. When you look after the different elements in our surrounding, we observe that all the total elements that are present in our surrounding classified into 4 categories, and which are placed a particular position in the modern or extended form of the periodic table. These are metals, non-metals, metalloids, and noble gases. I repeat again. All the total elements that came across in our surrounding is classified into specific 4 divisions. That is metals, non-metals, metalloids, and noble gases. In this chapter, we focus to only metals. The elements that are found in the nature, mainly 2 forms. One is elemental form, or not combined form, or in native form, and one is combined form. Mark that. 2 is there, 2 are there. One is elemental form or native form, and the second one is combined form. Discuss one by one. What is a native form? Elemental form, not combined form. That is, some elements are there which have no affinity towards oxygen, moisture, carbon dioxide of the atmosphere, and remain as such, are known as elemental form or native form. Generally, non-reactive elements are there, that is gold, platinum, noble gases comes under this category. Second one is combined form. Those elements possess a strong affinity towards moisture, oxygen, carbon dioxide of the atmosphere, and remain in the combined form, oxide form, hydroxide form, carbonate form, sulfide form. Then these are known as minerals. Another one point is there. In combined form, these are known as minerals. So what do you mean by mineral? Mineral is a combined form of an element which combines with the earthy and siliceous impurities like sand, clay, dust, along with the oxygen, moisture, and carbon dioxide of the atmosphere. atmosphere. These are known as mineral. For example, mark that bauxite, copper pyrite, galena, zinc blend, etc. It is Al2O3 2H2O. That is CuFeS2. That PbS, lead sulfide PbS, zinc sulfide ZnS. These are some examples of mineral. Next, we discuss another term is there, that is ore. That means in a combined form. In compound form, metal exists in again two different forms. One is as a mineral and one is as ore. What is ore? Ore is a mineral. Ore is a mineral from which metal is extracted economically and profitably. I repeat again. Ore is a mineral from which metal is extracted economically and profitably. It is to be noted that all minerals, all ores are one mineral, but all minerals are not ore. Very important one, mark that. I repeat again. All ores are mineral, while all minerals are not ore. If we look after some examples, that is, ore of aluminium is known as bauxite, ore of lead is known as galena, ore of zinc is known as zinc blend, ore of copper is known as copper pyrite. So every ore is one mineral, while every mineral may or may not be an ore. The metal that are extracted, the metal which are found in our earth crust, may not be, maximum cases, may not be in free form, in combined form. It combines with some earthy and siliceous impurities known as gangue or matrix. Known as so it is necessary to remove these unwanted impurities. The process of removing these earthy and siliceous unwanted impurities is known as metallurgy. Is known as metallurgy. And during extraction of a metal, some common procedure and processes are there. I repeat again. During the purification of a metal from its ore, during the extraction of metal from its ore, some common procedure and principal processes are there, which is known as general metallurgical operation. That is known as metallurgical operation. This process may be differ depending upon the impurities, depending upon the metal. However, there is some common processes are there, common steps that will follow during the extraction of a metal from its ore. These are point one. crushing and grinding of the ore. Next, concentration or mineral benefaction of the ore. Next, extraction of crude metal means impure metal, crude metal from the concentrated ore. And last one is refining. Mark that. These are the following steps which is common for all types of metal during the metallurgical operation. Point one is crushing and grinding. Its other name is pulverization of the ore. It is otherwise known as pulverization of ore. Second one is concentration or mineral benefaction. Third one is extraction of impure metal, crude metal from the concentrated ore. Last one is refining. Let us discuss one by one. First one is crushing and grinding. What do you mean by crushing and grinding? That means while digging by the machine, the metal in compound form that we get in the huge lumps which are difficult for the further operation. That's why that huge lumps of the metal in ore form is now converted into small pieces, crushed into small pieces by the help of a jaw crusher. By the help of jaw crusher. And then the small pieces made a powder by the help of a ball mill or stamp mill. By the help of ball mill or stamp mill. Mark that. The huge lumps are first broken down into, crushed into small pieces by the help of jaw crusher and then made a powder by the help of ball mill or stamp mill. This process, this is known as crushing and this is converted to powder form known as grinding. This process is otherwise known as pulverization of the ore. In powder form now it is easy to carry out the different steps for during the metallurgical operation. Next move to the second step, that is concentration of the ore. Second step, the powder form of the ore that we have generally contaminated with the impurities, that is the earthy and siliceous impurities known as gangue or matrix. Along with earthy and siliceous impurity, the metal in the ore is present either in oxide form, hydroxide form, carbonate form, in different form. That's why It is necessary to separate the impurities as far as possible. So depending upon the impurities, different processes are there which observed during concentration. The processes are gravity separation process, otherwise it is known as leviation. Second one, froth flotation process. Third one, magnetic separation process. Fourth one, leaching process. I repeat again. Depending upon the type of impurities present in the ore, generally 4 different steps are followed. One is gravity separation process, froth flotation process, magnetic separation process, and a leaching process. Let us discuss one by one. First one is gravity separation process. First one is gravity separation process. This method is employed for that ore in which the impurities becomes lighter while the ore becomes heavier. That means generally oxides of iron, cobalt, metals are generally concentrated by the gravity separation process. I repeat again. The principle behind this process is that the impurities are lighter one while the metal is the heavier one. So in this process, the powdered ore is spread over a slanting table having some ridges are there, and a current of water is blown over it. So as a result of which the lighter impurities, ganguine, matrix are washed away while leaving behind the heavier ore particles. I repeat again, this process is meant for the oxides of iron. Move to second one, that is froth flotation process. Second one, froth flotation process. This process is generally made for the sulfide ore. Very, very important 1 mark question. Froth flotation process is utilized for dash type of ore, sulfide ore. And the principle behind this process is that the heavier ore particles preferentially weighted in oil, the ore particle, the metal that is weighted in oil, while the impurities weighted dissolve in water. I repeat again. The ore dissolved in oil, preferentially weighted in oil, while impurities preferentially weighted in water. So in this process, the powder ore is transferred to a container in which water and some in little amount of pine or eucalyptus oil is there. Then that powdered ore is agitated in this container by passing through a current of air. As a result of which, the ore particle preferentially weighted in oil becomes lighter and moves to the upper part of the container along with froth. While the impurities which are preferentially weighted in water becomes heavier and settle down in the container. Finally, the froth are separated, dried and powder to get the ore. It is known as froth flotation process, and this process meant for sulfide ore. Very, very important one. That is, this process meant for sulfide ore. For example, PBS, ZNS, CuFeS2, that is galena, zinc blend, copper pyrite, next move to third one, that is magnetic separation process. Third one is magnetic separation process. This process is based upon the fact that the metal and the impurities differ in their magnetic behavior. I repeat again. The principle behind this process is that the metal and the impurities differ in their magnetic behavior. That means one is attracted towards a magnet while another is not. So in this process, the powdered ore is transferred to a hopper along with a roller, along with a belt, move over the two rollers. One is non-magnetic and one is magnetic. Mark that. One hopper is there. Again, two roller is there. For a roller, one is non-magnet, while this one is magnetic in nature, and it is a belt. So when we transport the powdered ore, then it is moves like this, and those particles are attracted towards the magnet or move away from it, keep some distance and form a heap, while those particles are not attracted towards the magnet, fell down, form another heap. Mark that. In this way, it is known as non-magnetic impurities. It is known as magnetic ore. In this way, the impurities is separated from the ore. This is about magnetic separation process. If these three, that is gravity separation process, cloth flotation process, and magnetic separation process fail for the concentration, the last one, the chemical process, which is known as leaching process. Fourth one, leaching process. It is a chemical process, and the principle of this process is that a suitable chemicals, it may be acid, base, or any other chemical substance added to the ore, such that in that chemicals ore dissolve, resulting in the formation of solution, while impurities remain as such in undissolved form and settle down at the bottom of the container. Suitable example is aluminium. Aluminium is extracted, aluminium is concentrated from its bauxite ore by this process. Mark that. That is Al2O3 dot 2H2O plus NaOH. The step 1. That means the powder bauxite ore, to the powder bauxite ore, concentrated solution, sodium hydroxide solution added to it, as a result of which the alumina Al2O3 dissolve in the solution, resulting in the formation of sodium metaaluminate. Sodium metaaluminate. Now it is separated and leaving behind the impurities. This sodium metaaluminate is filtered, separated from the container, and then it is dissolved in water to form a precipitate of aluminium hydroxide. Step 2. NaAlO2 sodium metaaluminate dissolve in water to form a precipitate aluminium hydroxide plus sodium hydroxide. That precipitate is filtered and finally heated to get the pure alumina. Mark that. Step 3. Aluminium hydroxide strongly heated to form alumina. It is all about the different steps followed during the concentration. So point 1, that is crushing and grinding over. Point 2, concentration or mineral benefaction over. Move to third one, that means extraction of crude metal from the concentrated ore. Move to the third step, that means extraction of crude metal from the concentrated ore. The third step is extraction of crude metal, means impure metal, from the concentrated ore. Generally, this process again carried out by two sub steps. One is conversion of concentrated ore into its oxide form. Point two, conversion of oxide ore to the metallic form by redox. Mark that. This process again carried out in two sub steps. That means conversion of concentrated ore into its oxide form, and B2, conversion of oxide form to its metallic form by reduction. That means the extraction of crude metal again follow two sub steps. One is concentrated ore transfer to oxide form. Then it is reduced to the metallic form. Let us discuss one by one. First one is conversion of the concentrated ore into its oxide form. First we discuss conversion of concentrated ore into its oxide form. Again, depending upon the impurities, depending upon the type of impurities, this process again carried out through two different ways. One is calcination and another one is roasting. Again, bit one is calcination, bit two is roasting. Mark that. The process of converting concentrated ore into its oxide form, depending upon the type of impurities, again moves through two sub steps. Either first one is calcination or second one is roasting. So let us discuss first what do we mean by calcination. First one we discuss, bit one, calcination. It's the important two mark question for council point of view. What do we mean by calcination? It is a process of heating the concentrated ore. It is a process of heating the concentrated ore below its melting point with a limited supply or absence of air. I repeat again. The process of heating the concentrated ore below its melting point with a limited supply or absence of air is known as concentrated ore. Generally, this principle is used for the carbonate ore. During this process, following steps should be observed. Mark that. Most important thing, this process is meant for carbonate ore. It is the process of heating the concentrated ore below its melting point with limited supply or absence of air. During this step, following observation made. Point 1, moisture is removed carbonate ore is transferred into its oxide form or becomes porous, which is easier for next step. And generally, this process of heating is carried out in a reverberatory furnace. This process is carried out in a reverberatory furnace. During this step, some chemical reactions are observed. Mark that. Wait one. Al2O3.2H2O upon heating. That means the hydrated ore loses its water molecule. Al2O3 plus 2H2O. Fe2O3.3H2O upon heating. Fe2O3 plus 3H2O. Some carbonate ores are there, that is CaCO3, CaO plus CO2. CaCO3 dot MgCO3 calcium carbonate, magnesium carbonate give rise to calcium oxide, magnesium oxide plus carbon dioxide. Copper carbonate dot copper hydroxide give rise to copper oxide plus carbon dioxide. Mark that. This one is known as dolomite. This one known as bauxite. This one is known as, it is an ore of copper, malachite. So these carbonate ore transfer to its oxide form. This hydrated form loses the water molecule, and ore becomes porous, which is easier for next processing. And the most important thing, this heating, strong heating is carried out in a furnace known as a reverberatory furnace below its melting point. Move to next one, that is roasting. Next process is known as roasting. What do you mean by roasting? It is a process of heating strongly. It is a process of heating strongly the concentrated ore in excess supply of air, but below its melting point. I repeat again. It is a process of strongly heating the concentrated ore with excess supply of air below its melting point. The most point of difference between calcination and roasting is there. Here in calcination, limited supply or absence of air, and in roasting, excess supply of air. But one similarity is there between these two. Both of them strongly heated, but below its melting point. Generally, this process is meant for the sulfide ore, and it is carried out in a reverberatory furnace. Mark that, important one for multiple choice question. This process is meant for sulfide ore. It is carried out. It is carried out in a reverberatory furnace. It is the process. It is the process of heating strongly. Process of heating strongly the concentrated ore with excess supply of air, excess supply of air below its melting point, below its melting point. Mark that. I repeat again. The most important thing is that it is a process of heating excess supply of air, and during this process following observations are made. Mark that. During this process, following observation are made. It is point 1. Moisture get removed. Point 2. Volatile impurities are removed in the form of their oxide. Mark that. Some examples, that is Fe2O3.3H2O. Upon heating, Fe2O3 plus 3H2O. Next, volatile impurities. S plus O2 give rise to SO2. P4 plus O2 give rise to P2O5. As plus O2 give rise to As2O3. Sb plus O2 give rise to Sb2O5. These are known as volatile impurities escape out, making the ore porous. And in this process, the sulfide ore got converted into its oxide ore. The most important thing that in calcination carbonate ore form to oxide form. Here sulfide form, sulfide ore transfer to oxide form. Mark that. Here sulfide form transfer to oxide form. Here sulfide form transfer to oxide form. For example, PbS plus O2 give rise to PbO plus SO2. ZnS plus O2 give rise to ZnO plus SO2. CO2S plus O2 give rise to CO2O plus SO2. Mark that. As a result of which ore becomes porous. And generally, this process meant for the sulfide ore, and this process heating is going on in a reformatory furnace. The most important 2-mark question: what do you mean by the term calcination? Define the term roasting. And last one, make a difference, distinction between calcination and roasting. Mark that. Next we discuss distinction between calcination and roasting. Distinction between calcination and roasting. The important 2-mark question. One side calcination, one side roasting. One important thing, all of you mark that. While writing the difference, always focus to point 1 is definition. So what is the point? First one. It is the process of heating the concentrated ore with absence of air. Point 1. It is the process of heating the concentrated ore with excess supply of air below its melting point. Below its melting point. Point 2. This method is meant for oxide ore. Point 2. This method meant for sulfide ore. Point 3. Here oxide ore is transferred into this method is meant for carbonate ore. carbonate ore. Here carbonate ore is transferred into its oxide form. Here sulfide ore is transferred into its oxide form. Mark that. Very, very important to mark question. First one is definition. Strongly heated below its melting point in absence of air. Strongly heated below its melting point with excess supply of air. Point 2. This method is meant for the carbonate ore. This method is meant for the sulfide ore. Here carbonate ore transfer to oxide form. Here sulfide ore transfer to its oxide form. This is the important to mark question. Distinction between calcination and roasting. That means step 1 is complete. Conversion of concentrated ore into its oxide form. Next step 2. Conversion of oxide ore into its reduced form. Depending upon the impurities, this process also carried out a different way. That is, reduction with carbon, hydrogen, aluminium, magnesium, zinc, or electrolytic reduction or auto reduction.